Name has several primitive types. Signed integers. Okay, so we learn more about the actual types. Not a lot, but still. Okay, so we have int 8, 16, 32, and 64. And int, where int is the same size as a pointer. Whatever size the pointer is. I guess if your 64-bit system, it'll be int 64. Okay. Unsigned integers are similar with u appended to the type as uint and whatever. Okay. Floating point numbers. Floating point numbers. Float 32, float 64, and float, where float is the processor's fastest type. I think I read somewhere where it actually always defaults to 64 for some reason. But it will be interesting to know how to check that. Characters. Character, which is basically an alias for uint 8. Okay. To indicate the size of an integer literal, append u or I and the size you'd like to the end. However, usually it's not necessary. Append u or I and the size you'd like to the end. We need to see that because I am not sure what the hell they're talking about. We have integer, int 8. Okay, integers can also have 0xx or 0o or 0bb prepended to indicate hex, octal, and or binary. Okay, so OX or OB for binary or OO for octal. Okay. Underscores are also valid in literals and can help with readability. Okay, so we can say 0x as in hexadecimal 7f. uint 8, and we just do 0b as binary, and we'll give it with the separator. Again, hexadecimal, and the type is integer. Okay, and uint 8. Okay, precedence rules are the same as in most other languages, but instead of those, operators are used respectively. Oh, instead of this, that, and that, we basically have XOR, AND, or shift right and shift left. Okay, I guess that will make it a little bit more readable. So I like that. And that, not sure why this is here. Kind of unrelated. Okay. Another difference that may be surprising is that the division operator returns a floating point result even when the operands are integer. If integer division is needed, use a div operator. Okay, makes sense. And all that. Well, that wasn't a lot, but at least we know how to create those specific ones. Types. Types are declared inside type sections, where multiple types can be declared. Note that alias types are the same, and not in any way incompatible with their original type. If type safety is desired, distinct types should be used. And that's another spot here. Yeah, we'll learn about it later. Okay, so I can say that there's a type, my integer, and that's, I presume, available in other modules, and that's an integer. So we can say that a is integer and give it 2, and we can easily take that integer and add it to my integer. I guess we're creating it here, or more like taking integer and converting into my integer. So they're basically the same and not in any way incompatible with these. So this is literally the same as this. There's no difference for the compiler other than you just saying my integer. Okay. I can see it as if you could define something like, let's say my type, right, is a sequence of integers, right? And that will be your type. So instead of writing this whole thing, or who knows what other longer thing, you can just do a quick thing and have a name and just go on, like a vector 3 or something, right? And that could be your array of 3 floats. Okay, and for now on it's vector, but it still acts as an array. There's nothing stopping you from passing an array to that, but instead of just writing that cumbersome thing every time, you just can use that. Okay, simple.